Hello and welcome to this month's edition of the Virtual Java User Group. I am Kim Fletcher and I am one of the organizers of the VJUG. While we wait for everyone to join, why not jump in the comments and let us know where you're joining from today. For today's session, the live session, please drop your questions in the YouTube chat so we can make sure that we get them answered for you. If you are watching this after the live stream, head over to our Slack channel where you can drop your questions in there and we'll be sure to try and get them answered. This is also the best place to stay in touch with what's happening, get to know the community and speakers a bit better. Awesome. So let's bring on your host, Holly, and speaker, Eric, for today's session, Avoiding Common Pitfalls with Modern Microservices Testing. Welcome both.
Thanks so much, Kim. And yeah, welcome, Eric.
Thanks.
Normally when I do this kind of thing, I say that I'm looking forward to seeing the talk, which is true. And this time, I am looking forward to seeing the talk, but I have to confess that I have already seen the talk, which, sort of makes me slightly less excited to see it compared to a talk that's brand new for me. And in fact, not only have I seen this talk before, I think I've delivered part of this talk with you and I've created some of the slides with you. So this is going to be sort of a fun trip down memory lane for me. And I'm looking forward to, to seeing what it looks like without me seeing it from the outside.
Yeah, I've watched myself and you on all the BCN and DevOps UK and whatnot, all watching us deliver it. And I hate watching myself talks. It's awful watching myself. And I hate my voice too. Listening to myself talk, it's oh, is that really what I sound like? But again, thank you. All the drawings here are you can see right on the title stuff. People can't see yet, but on the title slide here, drawings courtesy of Holly Cummins. I always ask you, where do you get your graphics from? And you're like, oh, I trace them and then I draw them on an iPad and whatnot. If someone says I'm not alone, I hate that. So thanks, and feel free to chime in anytime because I'm sure you've got a lot of color that you can add here.
Yeah, it should be good fun, and everybody else as well. Please feel free to share your comments on YouTube or on Slack or wherever you're watching it, on LinkedIn, and we can bring your questions to Eric. So I guess do you want to jump in and start with the slides?
Yeah. I guess I'll jump right in. So my name's Eric Deandrea. I'm a Java champion and a developer advocate at Red Hat. I've been at Red Hat for about 6 years, spent a lot of time in financial services before joining Red Hat. I've also written a book about Quarkus and Spring. I'm a contributor to a lot of different open source projects. So if you're not familiar with Quarkus or Spring or want to get to know it, I do have some resources for that. But really what kind of brings me to this particular topic is, I alluded to I was in financial services for a long time before joining Red Hat. And I know some of the struggles that we had when I was in financial services and even insurance, some of these big insurance companies was every time you touched something or one of your services or you deployed a microservice, even though all your tests were good, assuming you had tests, but every time you deployed it, everything else broke, right? And I don't know how many people can relate to that. I know I can relate to that. And I certainly know that when the microservices manual came out, that when I read it, it did not say that every time you touched one microservice that all the rest should break, right? So, microservices, kind of like the cloud, are supposed to fix all of your problems. So to try and start to solve those problems, we started to do lots and lots more end-to-end testing, which we found to kind of be a challenge because end-to-end tests are super expensive to do, and the whole ecosystem and the stars have to align on the 6th Tuesday of the month when there's a high tide. You kind of know where I'm going with that. All the teams have to come together, the data's got to be right, and you've got to have this environment where you can actually run all of your applications or all of your whole system with production grade data. and it's scheduled way ahead of time by someone who's not even technical, right? So it's certainly a challenge. And when we tried to do that, so we kind of figured out that by ourselves that there's got to be a better way to do this than having to do this end-to-end testing thing. And I guess the kind of the first disclaimer here is, even though I like testing and I talk a lot about testing, I am certainly no test expert. I'm not a contract testing expert. I know enough about it to know that it can help solve some problems, but I'm certainly no expert. But really, that's okay, because as developers, we all wear different hats. And supposedly, with this whole everybody heard about the whole shift left thing, years ago. You're supposed to do your testing earlier and test earlier. So I guess testing is part of every developer's job and every developer's workflow. So we all need to wear multiple hats here. But it kind of is unfortunate that testing is part of our job, not only because some of us don't like it, but it's hard to do. If you think about it, though, some people, it kind of goes against the principles of microservices. And if you go back to your microservices manual, then it should kind of think that testing your microservice is easy, because by definition, each service is really small and you can test it in isolation, right? And that's kind of the promise. But what we failed to see was that we don't necessarily care, or of course we do care, but we don't, in the bigger scheme of things, we don't necessarily care whether or not the individual services work. But what's more important, what the business really cares about, is that the system as a whole works, right? Obviously, if one system goes down, that's kind of like unit testing your entire system. If one system is broken, then obviously that's a problem. But you need to care about the system as a whole, because with microservices, it's not just one deployable thing that solves whatever the requirement or the business need is. And so what you typically find is your system starts to look like this, which, if you're not familiar with this is the Netflix architecture diagram. There's probably hundreds or thousands of what's that? Yeah, so it starts to kind of look, like what we call a Death Star diagram. Every system has this convoluted architecture diagram which tries to map the connections between all their systems together. And we start to call it your Death Star diagram, because it's so incomprehensible that you start to look at it. It's like, is that really my architecture? And it can quickly turn into something that's unpleasant. And I don't know if the music went through, but I really enjoyed this talk, because you can see in my t-shirt here, I really love Star Wars, and it's one of my favorite movie franchise of all time. And when Holly and I built this talk together, we figured out a way to strategically work references and analogies to Star Wars in them, because if I'm not mistaken, she's a pretty big fan as well. So we're both kind of geeky.
And I mean, it was so good, because this idea of the Death Star architecture, came from Adrian Copcroft, and it was already there. The analogy was already there. We just added the pictures.
You draw the pictures. I can't draw. Everybody said I was going to be a doctor, because nobody can read anything that I write. Right. So if you think about that, though, does the microservice, when we read the microservices manual, it seemed good, but does it solve all your problems? Or are we just doing it wrong? It kind of says one thing, and are we doing it the wrong way or a different way, or are we over optimistic about it, or do we have the wrong expectations? Just because you're doing it, it doesn't necessarily mean that all your problems go away. There's still lots of other things that you need to think about. And if you kind of look at a microservice, as you start to build one, okay, I've got one thing there. As you put two, and then it multiplies and starts to kind of grow crazy out of control, kind of like the hands or the tentacles of the Rathars here. A lot of times they actually start to cause more problems than you might even think that they're worth. They have all these different tentacles which go everywhere, and they touch lots of other things. And so testing them in isolation starts to become somewhat of a challenge here, kind of like kind of like the dynamics of a larger system as a whole, or Han Solo, if you've seen. And I always when I say episode 1, I always mean episode 4, because I'm of the generation where episode 4 was the first one. So that, A New Hope is the first one to me. The real episode 1 is the 5th episode to me. So I don't know, whatever, whichever one episode, the actual episode 1 works or is for you. You kind of remember that, Han Solo had these Rathars because he's always trying to make a quick buck, but then discovers that, there's trade-offs involved and it's not as easy or as it could be. But in this case, I guess the trade-offs helped because it ended up eating the people who were trying to capture him. But in any event, kind of back to testing microservices easy, because if you think about it, the services are small, everything's decoupled. You've got 1, 2, 3, 4, 5, 8, 7 or 8 points there on the line. If what happens if you remove the lines? The lines is where all the complexity is. So if you only test the dots and not the lines, does the thing actually work? Right, which is kind of goes back to the beginning point of this, where I have all my services, I run all my tests, all the tests are green, and I make one change and I put it into production and all hell breaks loose. Right, so testing the lines becomes super, super important. And some people start to get confused, and I liked when Holly kind of came up with this idea of get confused because microservices are distributed, and distributed starts with the letter D, so people assume just because they're distributed, they're decoupled. But and people will try to treat them as synonyms, but they're really not synonyms. They're not the same thing. You always need to have coupling, but I think what the problem sometimes is you don't really understand what the coupling is. You can have the largest distributed system in the world, kind of like that Netflix architecture diagram, but still have a very entangled domain model and be atrociously coupled. If anybody's gone down the road of trying to have a canonical domain model for all their microservices in their organization, is probably nodding their head and saying, "Yep, I know exactly what you're talking about. Been there, done that. Had the ice cream and dropped it on the floor." But the challenge is understanding the coupling. So if you talk about things that are being decoupled, that really means that you're not interacting at all. And if nothing is interacting, it's not a system. So I know Holly's very into Kent Beck and a lot of the other, some of the folks out there. And Kent Beck talks about managing the coupling rather than trying to decouple things. And so the first part of managing the coupling is trying to understand what that coupling is. And in fact, coupling isn't necessarily bad. And in most cases, it's actually required. So if you think about the pod racer here, there's 2 different kinds of coupling. There's the electronic thing that's going between the 2 pods, and then there's the cables that connect it back to the racer. And without either of those things, the pod racer wouldn't be able to function. It wouldn't be able to control. It wouldn't be able to do anything. But a lot of times you find that the problem is you don't know where the coupling is, especially if you're coming into a system that you're unfamiliar with or a system that already exists. And that's where things start to fail. And so actually, Holly, when we came up with this quote, or when you found this quote, we kind of like, who has seen or read that? I've actually started reading a lot of the series. I haven't gotten to this one yet, but I've been starting to read, but I'm reading from like the beginning, like chronologically, like from the beginning of time through some of the Star Wars series here. So I haven't quite gotten to this one yet, but I think the quote is definitely fitting. Anything that's left unsaid is where bad things happen or tragedies are built, trying to figure out where things are failing and where the coupling is. And certainly people will say, the first answer is, oh, we'll just write it down, right? And that's not really the right answer, because, the typical story is, you've got a 500 or so 1,000-page design document, back from the waterfall days, and you start to read it, and then you say, oh, I'm going to go start coding against it, and it's wrong, right? Or it breaks. And even like the demo example that I use, Holly and I joke about this too, because you did like the first incarnation of it and built it, and everything was, it works on my machine, great. And then it even had a nice README with lots of information in the repository. I forked and cloned it, and it didn't work, right? It's like, oh yeah, I forgot that I had done this into my environment and I didn't document it, right? So we're all familiar with that.
Yeah, and just to add for the sort of, the younger people, younger developers who might be watching this and think, oh, 500-page design document, that's an exaggeration. the first project I worked on had a literal 500-page design document that we had written, and on day 2 of development, it was wrong. So it used to happen, kids.
Yeah. Or it's just, it gets out of date, or, how often do you, even with like Java docs in your code, you write a Java doc for method, do you keep the Java docs up to date as you write the code? I mean, if you do, then, I'm going to give you a round of applause here, because, but I know I've been guilty plenty of times on it. You write the Java docs are great when you do it the first time, but it's hard to keep things up to date. But like, and then again, a lot of the design docs, they're wrong. Like, obviously they're not lies, and you didn't write the document to purposely try and deceive people, right? But so we're kind of exaggerating the analogy a little bit here, but the point is the documents themselves could potentially be wrong. So if somebody tells you what a particular protocol looks like, maybe they're not right, or maybe they read a document that was wrong, or maybe they, kind of like playing telephone back in the old day, you start by whispering something in somebody's ear, and then they whisper it, and by the time it gets all the way back to you, it's something completely different, based on interpretation, or by perspective, or by your viewpoint. And viewpoint is an interesting thing too, because what you might think might be right, someone else might perceive as being wrong, especially when you're talking between developers and product owners, or product managers, or scrum masters, right? The interpretation plays a big part in here. So, kind of going back to the repo, that Holly had, that, I read it, I looked at it, but there was something in there she forgot to mention. And so, yeah, it worked on her machine, but she had assumptions that she, in her brain, that she had baked in as to what the right behavior was, that wasn't necessarily documented. So kind of the point here, not to belabor the point, or belabor this too much more, is you've really got to figure things out. You can't just rely on the documentation and the theory. But kind of back to the paradox of, the stars have to align on the 6th Tuesday of each month and get every team in. So dealing with that is super expensive. So how do we do that? How do we try these things out? And I guess the first thing you need to do, especially, and I tell this to people too that are trying microservices or haven't done microservices and want to try it, is if you're not good at testing and you're not good at doing automation, then don't even go down that road in the first place, because you're going to run into trouble, because being able to successfully do microservices and to test microservices requires good testing and really good automation, good CI/CD, good DevOps practices, and all that stuff. And for a visual, I like, and Holly likes, the test pyramid here. If you're not familiar with this is a triangle, right? Yeah, the triangle. So we put things at the top and at the bottom. And if you think about the different kinds of tests, so if you think about the end-to-end tests, the ones that you deploy everything with real data and whatnot into your environment, yeah, it gives you a real high value and it gives you high realism, but also has a really high cost, and it has a high level of effort. Things at the top of the pyramid have high effort, but also have high value, right? And then you've got your unit tests at the bottom, which some would argue are hard to write. Others would argue they're easier to write, but they're, in relativity perspective, they're much easier than end-to-end tests, and they're really cheap to run. I mean, you can run them and run thousands of them in a couple of seconds, but they don't give you as much confidence in your system as a whole. And then in between somewhere, we have what we typically call integration tests, and this term, I think, has what's fluctuated the most over the last few years, or even the last decade, where different teams and technologies and whatnot that didn't exist before now exist today. So things like Spring and Quarkus and test containers and whatnot kind of start to blur these lines. Back 20 years ago, if you had said, hey, in my unit test, I'm going to make an HTTP request, or I'm going to talk to a real database, people would say, you're crazy. That's not a unit test. That's an integration test. But today, with the hardware that we have and containers and these other technologies, making an HTTP request or talking to a database as part of a test isn't necessarily a big deal. And so the more we can get to what the real system is and what the real system looks like in our testing phase, the better off we're going to be. So, and then if you think about unit testing, what do you typically do? You have a thing. If you need to integrate with something else, you do what? You build a mock of what you think the thing looks like based on the API or the documentation or what somebody told you it looks like. And so you kind of think you have something that fits there, and you build that, right? And so now when you run your tests, everything is good. Yay, green. But kind of going back to the other conversation, who's the best person to know what the other thing looks like? Because if you read the docs, maybe the docs are out of date, or maybe the person who told you was thinking about a different version, or you just, perspectives were different, and, the understanding of what you understood isn't exactly what they intended to be. So what ends up happening sometimes in reality is their code doesn't actually look like the mock, or maybe the API is good, but you get bitten by, you had to pass this, this field had to have a certain piece of data in order for the thing to work. And wasn't documented, and it's not, it might be a semantic thing, and it's not necessarily part of the API, or if you're using OpenAI, or not OpenAI, OpenAPI, excuse me, it's not in there. So when your unit test might be green, but when you deploy, reality is actually broken. And so what do you do, right? Because, the problem here is mocks are never perfect, or they weren't built correctly, or like I said, the documentation was wrong, or you misinterpreted it. And it kind of works out the way it did for Luke and Han in my episode 1, episode 4 here, when they're pretending to be stormtroopers so that they can save Princess Leia. At some point somebody realizes it's a fake, and it just doesn't work, and you end up in the garbage. And you think that would never happen, right? That would never happen to me. And this is kind of interesting, because Holly and I talked about how can we demonstrate this in a real life scenario, and we came up with this really simple, and it's almost, I don't want to say stupid, but it's like it might seem contrived and innocent, and it would never happen, but it's happened to me in real life several times, and I know it's happened to Holly several times in real life, which is why we decided to go with this example here. Right. And so because we're following the Star Wars theme, and we're looking at Star Wars and Princess Leia and Wookiees, we're going to talk about Wookiee carpets. Right. So if we go to our demo here, so I have a system up and running. And I'm going to go in my browser here. Host 80. Don't worry, I'll make the screen bigger in a second. So we have our Wookiee carpet shop, where we can order carpets made from Wookiee fur, right? Everybody would love a Wookiee carpet. So what can we order? I can order
as one does.
Yeah, as one does, right?
Totally realistic demo.
Totally realistic demo. So you can start to see some of the interactions between the different services. So we've got a microservices architecture here. We've got the user interface is one service. We've got the shop. Actually, the carpet shopper is the user interface, and it's responsible for interacting with this. This is a React-based UI, interacting with that. And then when you place an order for carpet, it's got to go to the weaver, because the weaver's got to weave the carpet. Part of the carpet is getting Wookiee fur, right? So you've got to go. We call it the Wookiee tamer. You got to go find a Wookiee and shave the Wookiee, and send the fur back up to the weaver. And one of the attributes here is whether the Wookiee tamer survived, because I don't know if you know, but Wookiees don't really like to be shaved. It takes a long time for the hair to grow back, so sometimes they don't necessarily survive. So it's actually a pretty high paying job, but it's very dangerous. You can go read Wikipedia about it if you want, and then you get the carpet back when you're done. So I could probably order a white carpet. Here's a question. You guys can chat amongst yourselves. What color Wookiees exist in nature? Chat amongst yourselves while we go here. All right. So I have this. You can start to see in the log here. I've got this application running. So we're going to look at just the backend two services, because everything that I say here could be applied, to between any producing and any consuming service. So we're just going to look at the Weaver service and the Wookiee Tamer service, and just pretend that we apply this to the carpet shopping service as well. So you notice here, all my tests are running. Everything's great. The application works. And then but you notice one thing here, which is kind of weird. At least it's weird for me, because I'm in the US and Holly's in the UK, the word color here is not actually spelled right. So we're just going to go ahead and change that. And this is kind of the contrived piece that we discussed before, where we said, oh, it's not really realistic, but it actually has happened to me in real life, where somebody changed something in the JSON schema and it flowed through and didn't get end-to-end tested. So I can just go in here and change this attribute, right? And I can call it color, right? It changes, and then, IntelliJ happily just goes through and changes all my code, refactors all my code. My tests still pass, but now if I come back to my system and I try to do a brown carpet, boop, 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 I get back a totally indescribable carpet, right? Because it passes in color, with the U, but it sends back something which then doesn't map. And then we start dealing with null and all that fun stuff. And at least it looks like there's some kind of resilience in there. So it didn't just blow up and get a big red X here, but we definitely didn't get what we wanted to get. I ordered a brown carpet and I got something that was indescribable. And what that means, I don't actually know. All right. So that's kind of example number one here. And so, yeah, it kind of leaves you like this. You've probably seen things like this. Your product manager, you get all your team together, you talk about all the requirements, but before you can actually build it, and you build all the pieces separately, and then you throw it together. This is actually a functioning sink, right? It has a knob. It pours water. The water goes down a drain. You can stop the water from going down the drain. It meets all the requirements, but it's certainly not what the user expected you to have. So how do we fix that? So let's look at some possible solutions. And I like to look at and use another analogy here is fire alarms, right? So one way to end-to-end test a fire alarm, whether the fire alarm works correctly, is to blow it up, right? And I'm sure it's not something we want to do. We hope that the fire alarm companies test it this way sometimes, but certainly not on the Death Star, because if you blow up the Death Star and as Luke is flying away and you hear beep, 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 beep from the fire alarms, then you know it worked. But, no, then you don't have a Death Star anymore. So, there's got to be a better way where we look at how we test these things using the interaction that we actually care about. But, our fire alarm manufacturers, if you haven't seen a fire alarm before, if you're that young, then this is what a fire alarm looks like. They've actually already anticipated this need. So you see the little button that you push, and everybody's supposed to push it. What is it? Once a month, Holly? Once every 6 weeks? Once every 2 months? I don't know. I don't push mine very often.
No, I'm going to go test all my fire alarms after this, because I think it's been like a year, 2 years.
Yeah. So you're supposed to push this button, and you're supposed to hear beep, 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 right? So it's been instrumented in a way for unit testing, right? But when you push the button, how much confidence does that give you that it's actually going to go beep, beep, beep when there's a real fire, right? Because the last time I checked, fires don't really have fingers, and the fire starts and it's like, ooh, there's people upstairs that are sleeping. I better go push this button so that I can warn them so that they get out, right? That's not how it happens. And, the button push is not the interaction that we actually care about in real life. That being said, you push a button and nothing happens. Well, that's a good indication that your alarm's busted, right? Either it needs a new battery, or the speaker's blown, or you just need to replace the thing. So it's a good unit test that would catch a defect, but it doesn't give you confidence that the fire alarm's actually going to go off when there's an actual fire or smoke or heat or whatever. There's lots of different types of detectors that are out there. So somebody better be doing more than that. So how do we test the interaction we care about without burning our house down? And this, when Holly brought this, I hadn't actually heard about this before, but I guess in institutions or companies or universities that have or commercial properties, they have these things that are on long telescoping poles, and so you telescope this thing up, you put it around the fire alarm, and then you push a button and it either injects heat or some smoke or something, and then the fire alarm goes off. And hopefully they've told the people that are occupying the building or space that they were going to do this before they did it. Otherwise, they're going to cause mass hysteria, and that's not good either. But essentially, that is a contract test, because you're providing a stimulus which is like the one that you actually care about in real life, and performing an assertion that you got the response what you expected to get without having to burn your house down. And just as an aside, if you really do want to burn the Death Star down, we did find somebody who sold Death Star fire pits. So somebody out in California sells these for about $3,000. I don't know if it's worth it or not, but if you want to see the Death Star burn, you actually can. So if we come back to our test pyramid here, we start to see, well, where do these contract tests fit in relation to all the rest? And it actually kind of breaks the model, because at first you would start to say, oh, it belongs up at the end-to-end test because it gives you high value. Well, that's true, but it's easy to write them, so you probably want to run them all the time, or they provide a good integration test. So it kind of breaks the model a little bit, because you could start to put it wherever. It kind of spans the whole triangle a little bit. And so if we go back to our mocking example, right, where you built something that looks like their code, the contract actually becomes the mock. So you have the contract between the two systems. For the consuming system, it becomes the mock. And for the system on the providing side, in this case, our Wookiee shaving service, it's actually a functional test for that application. So they can verify that they satisfy, that their application satisfies that contract, while the consuming service actually can verify that their code behaves to what the mock actually looks like. And as you change the contract, the mock changes, which of course will change the functional test, and then the service may continue to pass or fail. So in the case where everything is good, our tests are good. And when I say our, I'm on the consuming side. Our tests are good, their tests are good, reality is good. But if the producing service does something different, or they change the attribute, from color with a U to without the U, now the mock hasn't changed, the contract hasn't changed, but now their functional tests would be broken. So our test would be green, their test would be red, so we would know ahead of time that reality is going to be broken. Don't try to deploy these two things together. And similarly, if we change the contract and the mock changes, or we change our code outside of the mock, then obviously our code is going to be broken. Their functional tests will pass, and we'll know reality is broken. And so there's a bunch of different frameworks that are out there. They're, depending on whether you're looking at consumer-driven, provider-driven, we'll talk about those in a minute. But we're going to talk today about the Pact contract testing, and I like it for a couple of reasons. One, it's the one I see is mostly talked about out there. It's also very polyglot, so it's not just specific to Java. I know they have, I think, Python and Rust and did they have Go? They may have Go. I know there's JavaScript, so it's very polyglot. You can even use it in React. So like in your React code, you can use contract testing and use Pact in your front end tests as well. So let's see how the situation we ran into earlier could have saved our bacon, as Holly likes to say. That's a saying that I never used to use before, but I use it all the time now. All right. So back to our service here, right? So because I'm going to be working, and when Holly and I used to do this talk together, we would switch off the coding, just because we're going to work on two different services, and it would give a good visual of which service we're working on. But then I would throw a curveball at her, because I'm a former Eclipse user, and my IntelliJ has the Eclipse key bindings, and she'd be like, how do I do this? Because the key strokes are all different, and just that's kind of screw up. So what I've got here is I've got some hats. So the C, I don't know if you can see it. I've got a C hat for C for consumer. No, I'm not a Cincinnati Reds fan. And I've got a P hat here, P for provider or producer, whatever you want to call it. So I'm going to put on my C hat. So I'm going to be working in the consumer here. So the first thing I'm going to do is I'm going to open my test. So I've got a test for my REST resource here. And you notice, I have a mock. I have this Wookiee service here, which is my mock that kind of looks like what the Wookiee shaving service should be. I'm going to request fur, and this is what I think it looks like. And then I have a mock for that. And then I set up my mock, when I call get fur, then it's going to return brown. All right. So what we're going to do here is I'm just going to throw away all of the mock stuff, right? And what I'm going to do is I'm going to add annotation from the Pact framework that says this is a oops, that was the wrong one. Yeah, that was so this is a Pact consumer test. So I'm on the consumer side, and it's for the provider of the Wookiee tamer. And you notice I'm giving it this little port here, and we'll talk about that in a minute. So what Pact is going to do is it's actually going to stand up an endpoint that's going to serve the contract for the provider that my unit tests can now consume. Right. So depending on how I start to define this contract, I'm automatically going to get a mock server that serves that, and that's going to be running on that port. So now as I write my tests that use my API, I don't have to worry about mocking or stubbing because it's going to be a replica of what the contract is. And you notice the testing here, we're using Quarkus with continuous testing. It's already starting to fail because I haven't finished writing my tests here yet. So it's not that one here. So I can say, so I'm going to create a contract, and you think with all this AI stuff, it would know that the imports that I want, right? Because I've done this a lot. So I need to do some imports here. Yeah, I think that's right. So I'm going to define one more. There we go. So I'm going to define a contract where I say, when I receive a request for Wookiee fur to this HTTP path, /fur/order, given a certain set of headers, in this case, the content type of JSON, where it's a post, I want it to, and it has a body that kind of looks like this, where it has a color attribute. You notice it has the U here, and it has some number, and it has an example. So the mock will actually serve back this color brown. Then I want the mock to respond with, or the server, the producer should respond with an OK status with the same headers and a particular JSON body that has a color attribute with a sample value of brown, right? And now if I come down here and I say, oops, what is it here? So now, oops, I can bind the test. So when I have this test, I can bind this test to this contract. So I can say this is a Pact test for this particular contract. And when I save, you notice now all my tests pass again. But the cool thing it did behind the scenes, if we were to look in our target directory, there's this target. Where is it here? Reload from disk. I come in here, there's this target Pact. It actually generated a contract, which is this JSON document, right? The other kind of cool thing that I can do now is I can actually publish this contract to a broker. So I can say I have just a script that does, and it's just using the Maven plugin to do that. It's actually going to publish this contract to a broker. And that's how you start to share your contracts. And my brokers over here, there's the Pact broker is part of the Pact ecosystem. It comes as a container image. You can run it yourself. You can run it on Kubernetes. You can run it standalone. It's a Java application. You can run it outside of a container, or there's a SaaS service, and there's a free tier, which I don't like to pay for stuff. So I'm using their free tier. It's called Pact Flow. So in here, as soon as I deployed or I publish a contract, I can see I've got two applications here. I've got the Weaver and the Tamer. And if I go into the Weaver, I can start to see, well, there's a version 1.0 of the contract. And if I look at the contract here, where is it here? If I view the contract, it says, a request for Wookiee fur, and it tells me what the contract looks like, what the request should look like, and what an expected response should look like. But you notice it's got this little exclamation point here, and that means that the contract hasn't actually been verified. So the provider hasn't done a functional test to actually verify that the contract is valid, or that it meets the contract. So that's what we got to kind of go do now. So if I come over to my provider service, I'm going to switch my hats here. If I come over to my provider service, is the shaving service, right? This is where we made that change before. So now I'm going to write a contract test. It's not in source main. I'm going to do it in source test. So this is going to be my per resource contract verification tests, right? Right. And if I just copy in some stuff, you'll find if you go to the Pact, this might look like a decent amount of code, but if you go to the Pact website and look at how do you run a provider verification test, it's actually pretty boilerplate. For the most part, is it uses JUnit and it generates test templates, but it's generating a test template given the broker URL that I'm telling it, which is my Pact flow broker. So as soon as I save this, you notice it's running. It's actually going out to the broker. And it's fetching the contract and it's saying, hey, the contract between the weaver and the tamer failed because the contract says I should have color with a U and I'm returning color without the U, so it's failed. But the other kind of cool thing is I can come back to the broker now, and if I just refresh the page, sometimes it takes a second for it to update. They updated this recently and it's not completely Yep. So now if I view the contract, oops, it should say that the contract failed. It should have a fail. And it did earlier. Trust me. We all love it when things go wrong in demos, right?
Your demo was going too smoothly. Something had
there it's red. It's red now. It's eventually consistent, right? It's not transactional. It's eventually consistent. So now you can see that the functional test is there and it's actually published the fact that the test failed. So now you can someone can come in here and there's an API behind this too. So as part of your CI or whatnot, you could come in and you could query the broker and say, hey, I've got version 1 of this and version 2 of this. Can I deploy them together in the same environment? And it'll tell you yes or no, essentially. Now you'll know ahead of time that they're not contract compliant with each other. Right. So now if I come back and I refactor, kind of undo the change that I did before up here and put the U back, which it just looks wrong. Yep. Now my tests rerun and now my test passes and we'll see how eventually consistent this is. If I refresh this over here, it'll take a second or two. Like I said, eventual consistency. Yeah. It'll come back in a second. Weaver. Yeah, so now it's green. It just takes a minute, literally. So now the contract is green, and so now I know these two versions of things are compatible with each other, and I can deploy them together. Hooray!
Oh, and we've got people are paying attention as well. So someone has pointed out that you forgot to change your hat.
No, this is the provider. This is P. I'm on the provider side. I'm wearing the right hat.
You're wearing the right hat.
I'm wearing the right hat.
You're on top of it.
I'm on top of it. I am wearing the right hat, am I?
I think you're wearing the right hat.
I think I'm wearing the right hat. Yeah, Wookiee Tamer. Yeah. I'm working the Tamer. That's the provider. P is for provider, right?
Yeah, because I guess you could fix it in two ways, couldn't you? So you could go and ripple the change through the system and say, hey consumer, you need to update your expectations because I'm spelling this the incorrect way. Or you could say, okay, as a producer, I have realized the error of my ways and I'm going to go back to the correct spelling, and you've done the second fix.
Yeah, but the important part is that they had to communicate with each other, right? So we've had to establish a communication channel between the consumer and the provider, which is sometimes harder to do than you might think within a larger organization. One team doesn't necessarily know about the other team, which is kind of a case of when you might want to use Pact and when you might not want to, which kind of is a very nice segue into the next, almost as if you would know. Right. So, but one of the kind of the if your head hasn't gone like this, so is that the consumer is driving the creation of the contract. People who are familiar with contracts or things like Microx or Spring Cloud Contract or these types of things, these are all provider-driven contract frameworks where the team that's building the provider, like the RESTful service, is the one defining the contract and sharing the contract. Pact kind of takes that and flips it on its head. So now it's actually the consumer that's driving that contract. Yeah. So it's well worth kind of who would have thought it. So start to look at what this looks like. In consumer-driven contract, everything starts with your consumer. And the consumer tests create or declare the contract, and the contract provides the mock for that consumer to use in its tests, like we just saw. And then the provider can query the broker, and because the provider knows who it is, the contract has the two parties that the contract is between. And so the provider can say, hey, I'm a provider for this thing. Show me all the contracts across all the consumers that I need to verify against. And the provider can then develop to the contract, which is kind of like TDD, right? If you think about test-driven development, you write your tests before you write your code. Now your consumer is actually telling the provider what functionality they actually need to build versus, your typical microservice thing. With like REST endpoints, you build them all and you don't use half of them, right? So now you only have to build what your consumers are actually looking for. But on the flip side here, one of the good things that you can do is that you can do semantic testing. So I alluded to earlier, maybe there's some field that has like a magic value in the payload that has to be set. With things like OpenAPI, OpenAPI is basically just giving you the type safety, like that the payload, the body has to look like this, but it doesn't have a way to describe what the semantics of what it actually means inside, which is something you can do with Pact. And then, like I said, you can develop to the contract. But on the flip side, is Pact as its own spec, it's its own schema. So if you're doing OpenAPI spec is not a Pact spec, and vice versa. So existing assets that you might already have, you can't really repurpose them. A big one in this case is that the provider needs to know who its consumers are, right? In order for this to work. If the consumer is driving the contract, well, now the consumer and the provider need to know each other. They have to be able to talk to each other, and the provider has to know who the consumers are. So if you're building like the weather service or some public facing service out on the internet that random things can call, Pact probably is, or consumer driven contract testing is probably not the best solution for that, because the consumer can't say, I want the weather to be sunny on Thursday, which it is here, but it's still a little chilly, right? And the other thing that you can do is your consumer can do something or publish a new version of the contract, which then the broker has all these webhooks and stuff, which could trigger a CI run of your provider, and your provider's CI can now break, even though the provider hasn't made a single change. So the consumers can now break your provider's CI, which I guess is a good thing. But it kind of starts to get confusing and to wrap your head around it. But I guess where I go with this, if you're doing something is better than nothing. So if you're doing these other things like OpenAPI or Swagger or whatnot, then you're doing provider-driven contract testing and not consumer contract testing. And there's a difference between them, right? So in provider-driven contract testing, you've got the provider. You're probably building something because you at least have one consumer. Maybe you don't, but sometimes if you're within an organization and you're building an internal app, there's probably at least a requirement for some kind of consumer for whatever it is that you're providing. And you've got to have some kind of connection between the two. So the provider might generate an OpenAPI doc, or maybe use something like Schema Thesis or Microx, or Microx can serve and do contract testing based on OpenAPI as well. And then the provider can verify themselves against their own contract, but they've still got to figure out a way to share that contract with the consumer, and the consumer has to still build a mock around that using something like Microx or Prism, or there's a bunch of other tools that are out there to do that. So kind of the benefits of provider driven is you get the familiar contracts. If you're doing OpenAPI, for example, the provider doesn't necessarily need to know or communicate with its consumer. But kind of on the downside, the provider doesn't get insight into how their API is used. So with consumer-driven contract, because the consumers are driving the requirements, which consumers are doing what. Whereas unless you build that somehow into your architecture somehow, just out of the box, your provider doesn't necessarily know what's being used and how it's being used. And I started to talk about like the semantics of it as well, like being able to understand relationships between things that are actually in the contract, not just the structure of the contract. So So is it enough? I'd say it's better than nothing. Like if you're not doing anything, at least getting you to that, I think will help stop a lot of problems from existing. But like I said, you can't say, hey, if I give you A, I expect B, but if I give you X, I expect Y, given the same structure or the payloads or the within the body or the query parameters or the headers or the data or something like that. And so you end up in situations where you look the same, but it's actually different because the semantics are different, right? So in the example where they're walking Chewie down, to the jail cell there, it looks like a stormtrooper, but it acts like Luke does because it is actually Luke. So anybody get any answers? I asked the question, what color Wookiees occur naturally? Who's got an answer? All right.
So far, we have been completely disappointed by our audience.
Yeah, come on, people. Let's get with it.
Yeah.
Come on, Wikipedia. This should be like on the tip of your tongue here. Like, what color Wookiees exist in nature? You've got brown Wookiees. I think you've got gray Wookiees. You've got black Wookiees, and I think white Wookiees. Are there any others? Maybe tan. But could it be completely indescribable to want like a pink or a green carpet or a blue carpet, even though those color Wookiees don't exist in reality, right? So how would we do that? If I wanted to come back here and I wanted a pink Wookiee or a pink carpet, right? What would happen? So it's going to go, I'm going to get back and I got a brown carpet. Ooh, but that's not what I asked for, right? Because what happened here? The weaver said, hey, I need pink fur. The shaving says, okay, pink fur, but you're going to get brown because pink Wookiees don't exist in nature. And so I got brown. So I've got some resilience in there, but that's not really what the user wanted. So we kind of got to think about, well, we probably need some kind of dyeing service in here. So we've just kind of uncovered something that we need to build. Either there needs to be another dyeing service in the middle, or the weaver's got to dye it, or the Wookiee shaver's got to dye the fur before he sends it back. Personally, I feel like the Wookiee shaver is barely escaping with their lives. So having them have to do dyeing probably, I don't know, feels wrong to me, but to each their own. So in any event, we
dyeing is totally overloaded in this context. Which
I'm kind of doing that on purpose too, huh?
Yeah.
Kind of doing that on purpose. Dying and dying, DYE, DIE. So we need to have it in our contract where the structure is the same, but we need to be able to accommodate for essentially colors that don't exist in nature and be able to handle that and do something. Because if we don't want to dye it, then we need to tell the user, well, they're not going to just get it. You get what you get, and you don't get upset. They didn't ask for a brown carpet. They asked for a pink carpet. So either you need to tell them, I can't give you a pink carpet. Would you like a brown one instead? Or you need to give them their money back. Or you need to figure out a way to weave pink carpets. But in any event, giving them brown isn't the right answer. So how would we fix this here? So let's go back here. I'm going to switch my hats because Peter said I was wearing the wrong hat before, and I want to make sure I'm always wearing the right hat here. All right, so now we're going to come back to our Weaver service, right? So in my original contract where we have this, I'm going to introduce something new here. And I'm going to say a contract that looks kind of similar, but instead of in my body, if you look down here where it's a string type, now I'm just saying it's a string value. So instead of any string, I'm specifically looking for a color I know doesn't exist or that the service might not know about. In this case, it's pink. It could be something else. So I'm describing a specific value, not just any potential string. So the structure is exactly the same. And so when I ask for pink fur, I'm expecting that it's going to return with a 404, right? We could have over a couple of beers, have a conversation about 404 and 20. Do you return 204 with empty? Do you return an exception type? Do you return 404? This, we go out for a couple of beers and I'll convince you why 404 is the right answer here. But more on that later. So now we'll come and we'll actually write a test for this. So now I can say, I can write a test, which given a carpet order for pink, when I get back, I get a different status code. And I just kind of picked 418 here because now if you think about this distributed service, I have the Wookiee's going to give a 404 back, but what does the Weaver need to do to communicate back up that, hey, I can't weave you a a pink carpet. So lots of different ways to do this. We chose just a different status code, and we picked 418. Anybody know what 418 is? It's the I am a teapot status here. It was kind of an April Fool's joke way back when it actually made it into the spec. Essentially, we're telling the shopper that, hey, I couldn't do it, and you need to change your behavior or do something different when you see that. So that's what we're going to do here. And when I save, my tests actually fail because expected a 418, but it was actually a 500. So this means that my code, when the mock server gives me back a 404, my code doesn't actually handle this properly. So we've got to go and we've got a bug in our application that we've got to go fix. And the bug is in here somewhere. And so I'm going to do what every good developer does. I'm just going to surround the whole thing with a try catch because I don't have enough time to actually debug it. And I'm going to catch with web application exception E. And then I'm just going to throw a new not found exception. And I'm going to put the color in the exception, right? As soon as I save that, my test runs. Oops, I forgot my semicolon. My test runs, and now my test passed, right? So one kind of interesting thing with Pact is because I already published a V1 of the contract, and that's already been verified, I can't republish. This is essentially it's an addition to the contract. I can't publish the same version of the contract. I have to publish a new version of the contract. So I'm going to publish a 2.0 version of the contract here. Right. And so now when I come back to my broker here, we'll see how eventually consistent this is. So I come into my applications, I've got my Weaver, version 2 is there. So now I've got version 2, and I've got the two parts of the contract that are there. They're both exclamation points because they haven't been verified yet, right? So now we go over, let me switch my hats here. We go over to the Wookiee shaver, right? And so in my Wookiee shaver here, I'm going to come back to my test class and just hit the S key to trigger a save, and it's going to rerun, and it's going to pull version 2 of the contract, and it says, hey, I expect you, when I get pink, I expect the 404, but you actually gave me a 200. So now, I've got a problem here, so I've got to go fix that as well. So if I go into my fur resource class, you notice I've got some exception handling. If I look for a color that I don't have, I actually give brown. So now, instead of returning brown, I'm just going to return null. We all like null. What does null actually mean? Anybody know? Right. Also, null means 204, right? In JAX RS or Jakarta RS, if you return an empty body, Quarkus will automatically return a 204 for you, which isn't what I want. But at this point, kind of like Holly said before, I don't really care. I don't want to have an argument of 204 versus 404. So what I'm going to do is I'm going to go like we all do with all of our tests is we know what reality looks like. So I'm actually going to change my test to match reality, right? So if I come back up to my contract here, so instead of not found, I'm going to say no content, right? And as soon as I save that, now that runs, and now my test fails, right? Because now it's expecting a 418, but when I get a no content, now I'm actually blowing up. I'm getting a 500. So that's not good. So essentially, we've got this problem now where both sides are broken, right? And I could publish a new version of the contract here, and we could see all that, but both sides are now busted. So now Mr. Consumer needs to go back to, oops, and I should have changed my hat. Sorry, Peter. When I did this, I should have changed my hat. Crap, you caught me. So when the producer, I tried to cheat and say, oh, I know that my producer or my producer is going to give me a 204 instead of a 404. I'm just going to go change my test so that it matches reality. But I actually can't, because now something's broken in my code, and now I need to go fix that, or I have to communicate back with the provider and say, hey, can you change it back to a 4.4? The point being, we actually have to talk to each other, and we have to have a conversation, and we've got to sort this out. Kind of like in real life, and Holly and I actually had this conversation when we were building this talk. I don't know if you remember this, but it was like late at night for you. You're 5 hours ahead of me, so it was really late at night, and you were trying to do something, and you probably tell the story better than I do. You remember better than I do.
But yeah, exactly as you say, I couldn't make it work. And so eventually I was like, I'm just going to change the expectations in my test to make everything pass. And so I fixed it on the provider side, but then my consumer started breaking because my consumer didn't work with the 204 that I was now expecting instead of the 404. And so it catches those problems where, you can't just change your test expectation and hope that the real system is going to work. The real system actually is the thing that you care about, not just making your test green.
Right. Yep. And this was kind of an inside look to what happens at Red Hat. This was a screenshot of an actual conversation that we had on our chat system before we moved to Slack, I think. All right. So what does that mean? So to kind of wrap up a little bit here. So microservices testing is hard, right? If it was easy, everybody would do it, but we all need to do it, but it's definitely hard. And the typical solution of throwing everything in an environment and do your end-to-end testing, while great, and that's the best way to do it and the way you're going to get the most value and realism, it's also the most expensive option. Whereas something like contract testing, I didn't have to deploy anything anywhere, right? It's kind of like a unit test, but gives me much greater realism and value, almost like an end-to-end test. So it's not quite end-to-end, but it gives you a lot more realism than a simple unit test, because the mocks aren't going to be enough, especially when you're building the mocks while maybe your provider is in the middle of an iteration and you're building the mocks and you're trying to keep up and things change and they don't get written down, and for all the same reasons we talked about at the introduction to this. So, contract testing, whether you're doing consumer driven or provider driven, some form of contract testing is a good thing. And even if you do a little bit of it, it's going to get you far down the road than if you aren't doing it at all. I mean, I know other organizations are using Pact or Microx or Spring Cloud Contract. I used Spring Cloud Contract in my former life, and we had a framework and we had a way to store them and ship them and whatnot. And it worked okay for what we were doing. So it kind of depends on how your organization is structured, whether there's clear lines of communication between your consumers and your providers. So with that being said, just a couple resources. If you're not familiar with Quarkus and want to see it in action with fewer Wookiees, there's the sample application that's out there. I'm the primary maintainer of that. There's a bunch of good books that are out there, reactive systems. I know Antonio's got a new book on laying chain for J that's out there as well. And I think that's about it. And so the QR code here will bring you to the slides. The slides should be there. If they're not there, somebody find me on Slack. They should be there now. And I think that's it. I think it's like exactly an hour.
Yeah, perfect timing. Yeah, thank you so much, Eric. And yeah, just to echo what Eric said, if anybody would like the slides or any of the other resources, we've shared links to those in the comments. If you'd like to continue the conversation and argue with Eric about the 204 and 404 semantics, we've got the VJUG Slack channel, and so you can continue that conversation there. But with that, I think the only thing left to me is thank you very, very much. I enjoyed watching the talk from the other side. And yeah, hopefully everybody else did too.
Yep. We can't hear you, Kim.
Awesome. Every time. No, thank you both so much. That was a really, really good session and really interesting. And hopefully we'll have you back soon. But yes, as Holly said, all the links have been shared in the chat, as well as over on Slack. So do go and check them out.
And I've got, sorry, Kim, I've got one more thing before you completely finish this off. Because I remember one of the things that came out in the chat early when you were talking, Eric, was someone saying that they have the hard copy of your book, and big thank you for that. So love for your book in the chat.
I think I've been saying for a year now that there's a V2 coming, and it's still coming. Anybody who's written a book, that's like the typical response for anybody who's written a book.
Yeah, it's 80% done, right?
Yeah. So the next 20% takes 80% of the time.
Nice. We won't hold you to a date. Fantastic. Well, for everyone else, thanks for joining. And we will be running our VJUG Connect session live from the Chicago Java user group next Thursday, the 27th of February. So you can head over to the meetup page to get more information on that. And if any of the other Java user groups want to get involved, the VJug Connect is live streaming in-person sessions right here. So we can spread more of the awesome speakers and content that is going on live. So DM me if you want any more information. But otherwise, take care and we'll see you all soon.
See you all.